In this video, we are going to discuss user role firewall. The agenda for this video will be, we'll first discuss a brief overview of user role firewall. Then we'll implement user role firewall. Then we'll see how to monitor user role firewall. In the end, we'll see how to troubleshoot user role firewall. Network security enforcement, monitoring and reporting based solely on IP information soon will not be sufficient for today's dynamic and mobile workforce. By integrating user firewall policies, administrators can permit or restrict network access of employees, contractors, partners, and other users based on the roles they are assigned to. User role firewalls enable greater threat mitigation, provide more information forensic resources, improve record archiving for regulatory compliance, and enhance routine access provisioning. Now, user role firewalls trigger two actions. First one is they retrieve user and role information for respective traffic if and only if source identity keyword is specified. Secondly, they determine action based on 6-tuple as opposed to 5-tuple match. If IP address is matched in user authentication or identification tables, then user is classified as authenticated. If there is no IP address in user identification tables, then user is classified as unauthenticated. Let's see how firewall policies in which source identity keyword is used are matched on an SRX device. These are 5 policies on the SRX device, and similarly we have these 4 usernames which are bound to these 4 source IP addresses and these roles. For flow number 1, from trust to untrust zone, from IP address ABCD to EFGH, for port 80, which is initiated by user A. And if we look in the first table, this policy is matched, which is P1 for this flow, because policy 2 is for FTP, therefore just policy 1 is matched. For flow 2, from trust to untrust zone, from any source IP address to any destination IP address, for FTP and initiated by user C, which is in contract role. So this policy won't match because the application is different. And if we see FTP, but here source identity is different, therefore this traffic will be dropped by the default policy. For third flow, from trust to untrust zone, from any source IP address to any destination IP address, initiated by user E, and since we do not have a mapping for user E in our user identification tables, it should match on unauthenticated user, and it will match on policy 4 and will get denied. Note that policies with source identity keyword are terminal. On the SRX series device, the user identification table contains the IP address, username, and role information for each authenticated user. Entries are ordered by IP address. When username and role information is required by a security policy, all UITs are checked. Finding the IP address in an entry in one of the UITs means that the user at that address has already been successfully authenticated. Each authentication source maintains its own UIT independently and provides query functions for accessing data. 3 types of UITs are supported. First one is the local authentication table, then we have UAC authentication table, and in the end we have firewall authentication table. Local authentication table is static in nature, UAC authentication table is dynamic in nature, and so is firewall authentication table. All user properties are authenticated for local authentication table, and similarly for UAC and firewall authentication table. There are no real-time updates for local authentication table, but real-time updates are supported for UAC and firewall authentication table. Local authentication tables are generated from the CLI or programmatically. UAC authentication tables are retrieved from Junos Pulse Access Control Service or Pulse Policy Secure. Firewall authentication tables are retrieved from firewall authentication using local authentication, sources such as LDAP, Radius Secure ID. Local authentication table offers a backup solution. UAC is a primary solution, and firewall authentication table can serve as primary or backup solution. Local authentication table supports 65 character usernames, 64 character role names, and 10 to 40 entries. UAC authentication table is limited by Junos Pulse Access Control Service Pulse policy secure limitations, and so is firewall authentication. The default priority for local authentication table is 100, for UAC is 200, for firewall authentication table it's 150. Let's do a user role firewall lab. In this lab we have a two-armed firewall with one arm in untrust zone and another arm in trust zone. Our first requirement is we have to allow full access from CEO's group to trust network. Our second requirement is we have to allow full access from a manager's group to trust network. And our last requirement is all other users should first be authenticated by firewall authentication and then allowed access to the trust network. Now for the first requirement, I'll first go under Edit Security, User Identification, and Authentication Source. Under Edit Security, User Identification, and set Authentication Source. And you can see that these are the default priorities for local authentication table, which is 100. Then we have Aruba ClearPass authentication table, which is 110. And then Active Directory authentication table will be checked, which is 125. Then firewall authentication, and in the end, Unified Access Control will be checked. After that, I'll move out of the configuration prompt, and I'll do request security user identification local authentication table, and I'll manually add an entry for an IP address of 1.1.1.1. Roles is going to be CEO. Username is going to be CEO1. And after that, I'll move under Edit Security Policies. From zone untrust to zone trust, set policy CEO policy. Match source address. CEO PC destination address is going to be trust network. Application is going to be any. Then we have an option of source identity, and in this identity I can either match on the username or the user group, but since I should match on user group because it was stated in the question. After that, I'll do then permit, then log session init and log session close. For second requirement, let me first commit this configuration. For second requirement, I'll again issue the same command, request security user identification local authentication table, add IP address 1.1.1.2, and roles is going to be manager. Username is going to be manager1. Then if I run the command show security user identification local authentication table all, you can see that these are the two usernames and these are two roles for these source IP addresses. Then I'll move under Edit Security Policies from zone untrust to zone trust, set policy manager policy, match source address manager PC, destination address trust network, application any, source identity. I can match on user or role, but I'll match on role since that was stated in the question. And then permit, then log session initiation and log session closure. For third requirement, I'll first move under top edit access profile under top edit access and I'll set a profile named access profile. This is for for firewall authentication, and then I'm going to create a client. Name is going to be random. Client group is going to be random users, and it is going to be a firewall user with password ABC123. Then I'm going to set firewall authentication, web authentication, default profile, the access profile which I created before. After that, I'll move under top edit security policies from zone untrust to zone trust. Now first I'm going to create a catch all policy. Match source address any, destination address trust network, application any, and source identity I'll first match on unknown and or unauthenticated user. I'm then going to permit and log session initiation and log session closure. Then I'm going to make a policy authenticated random users, match source address random PC, destination address trust network, application any, source identity this time is going to be authenticated users which have been authenticated by firewall authentication. Then permit, then log session close, log session initiation. One additional very important command for this catch all policy is going to be set a policy catch all, then permit firewall authentication, and we are going to redirect this firewall authentication user tables to be used as user firewall, and we are going to use an access profile which we created before. Now I'll reorder my policies. I'll insert policy random authenticated random users before policy catch all. Now first we'll match on CEO policy, then manager policy, then authenticated random users, and in the end we have a catch all policy with firewall user authentication attached to it. After that I'll commit my configuration and we'll move to verification. Before verification, I'll move under edit system syslog, set file policy logs, match RT flow any. Now I'll commit my configuration and we'll move to verification. For verification, I'll first issue telnet to 10.10.2.2 an address in trust zone from routing instance untrust 1, which is CEO PC, on port 80, and you can see that the session is open and it was matched on this log and it states CEO policy, and this is the username and role. After that, if I initiate a session from untrust 2, which is manager's PC, then this is the log. and you can see the username and role. Now from a random PC, if I browse to 10.10.2.1, first I am prompted to do firewall authentication. And after that, I'm redirected to my HTTP web page. On the SRX, if I do show log user log users, and I move to the end of this log file, you can see that first catch all policy was matched on, and it was an unknown user. And after authentication, whose output we can see with show security firewall authentication users. And after authentication, if we move to the end of this log file, you can see that we matched on authenticated random users policy. And let me find the username which should be mentioned here, which was authenticated users. But since we are matching this policy, it implies that we were matching authenticated users.